Hi all, let's see stack and heap memory in C Sharp. Before seeing stack and heap memory, let's see what is memory management. Memory management involves allocating and deallocating memory resources during program execution to optimize memory usage efficiently. In .NET, CLR, that is Common Language Runtime, is responsible for managing memory. There are two types of memory allocation. One is stack memory and another one is heap memory. Let's see stack memory first. Stack memory used to store local variables and function called information. It operates on last in first out principle. Let's see an example. Inside this function, declared a variable a and b and assigned 10 into a and 20 into b and created an object for test class. When the first line of this function executed, compiler allocates some memory in stack, and if it's a value type means compiler store the variable along with the data in stack itself. Here note a is an integer value, integer is a value type, so value of a 10 stored in stack memory itself. And note, remember, stack memory hold primitive data type variables along with the data. That means the reference of variable a along with the data 10 stored in stack memory itself. And when the second line of this function executed, stack allocates memory on top of the first memory allocation, that is variable a. Whenever a new line executed, stack added that information on top only because stack operates on last in first out principle. And in the third line, we created an object for class. Note, class is a reference type. When it's a reference type, the reference of object only stored in stack, the data will stored in heap, that we will see in our heap memory. Now let's complete stack here. So if it's a reference type means only reference only stored in stack, and in the next line we entered the function. So once the function finishes execution, a, b and object reference automatically deallocated, that means removed from the stack. So let's see a quick recap. When a method is called, a block of memory, that is a stack frame, is allocated for local variables and parameters. If the variable is value type, for example int, float, double, that is primitive data type means data along with the variable will stored in stack itself. If the variable is reference type means only reference of that variable only stored in stack. These variables stored in the stack are only available during the lifetime of the method call. When the method ends, the variables are automatically removed from the stacks. That means the block becomes unused and can be used for next method call. Next, let's see heap memory. Heap memory is used for reference type, for example class, arrays, delegates, interface. Memory in heap is allocated dynamically and is managed by garbage collector. That means once the function completed execution, the values of object remains in heap memory until garbage collector removes it. Let's see an example. Here created a test class. This test class having only one property, register number. Then inside the test method declared an integer variable. When this line executed, it's a value type, so the value along with the variable stored in stack itself. In the next line created an object for test class. And note, class is a reference type. We know that every reference type values will store in heap memory. So when this line executed, the default value of this object, for example here register number is an integer, the default value of integer is 0, so that default value will store in heap memory and reference of that object will store in stack memory initially. And in the next line, assigned register number as 123. When this line executed, the value of register number updated in heap memory. And in the next line created object 2 for test class and assigned object 1 into object 2. When this line executed, the reference, that is memory address of object 1, will copy into object 2, and also compiler create a reference for object 2 in stack memory. Now both object 1 and object 2 reference in stack memory pointed to the same memory address where the data stored in heap memory. So if I change object 1 means object 2 also modified. Once the function finishes execution, the object reference and variables in stack removed automatically, but object remains in heap until garbage collector remove it. So stack memory maintains value types, method calls and reference of heap, and heap memory maintains object of reference types. Stack memory is faster than heap because it's fixed and limited, but heap memory is flexible and larger. Stack memory removed when the method exists, but the object remains in heap memory until the garbage collector removes it. If you want to know how to implement iDisposable and how garbage collector work, the video given in description box, please check that. Let's compare the stack versus heap memory concept with the bank locker analogy to remember easily. Consider bank locker as heap memory where actual valuables, that is data, will store, and locker key as stack memory which holds the reference to access the locker valuables, that is data. Like this, compiler using stack reference to access data from heap memory. And also locker key is a small and easy to carry, that is stack memory, because it's hold only reference, but locker, that is heap memory, holds the actual content. And if you copy the key, it doesn't create a new locker, it just provide another way to access the same locker. Like this, in reference type objects, if you copy one object into another object, it doesn't create a new data, same data shared by all the objects. Then if you lose all the keys, the locker still exists until the bank decides to clear unclaimed lockers. Like this, stack memory cleared when method exit, but data in heap memory will not clear until garbage collector clears it. Thanks for watching. If you found this video helpful, please like and subscribe to my channel.